Okay, today we're going to be looking at wind belts. So I'm going to mark this wind belts. And what I have here is just a basic circle. It is our Earth, and I drew the equator on it. Okay, so I'll label this equator. Now, wind belts are going to be driven primarily by the sun. So I'll go directly above the equator. Okay, I'll draw a little sunshine out here. Okay, there's my sunshine. I can color it yellow if I want, just so it reminds me it's the sunshine. So here's our sunshine. Now, what happens with the sun is it's going to cause air to rise. Okay, and so we get uplift of air here, right underneath the equator, right underneath the sun. Okay, so that is the beginning of our wind belts, because rising air it's going to make the air move, and you're going to bring in air from other locations. Now, let me draw, let's see, right up there, I'm going to draw an ice cap. Now, the ice cap, I'm going to draw it kind of three-dimensional to remind you that it is an ice cap. Okay. Okay. Now, if you've ever been to a Halloween party or somewhere where they have dry ice, what happens with dry ice is that air above the dry ice sinks down to the dry ice, and so you get this cloud that blows off, you got dry ice. That's just like the North Pole. Okay, cold air is going to descend on it. Okay, same thing down the South Pole. Now let's see if I can draw this upside down ice cap for you. It's much more difficult to draw upside down than right side up, even if it is just jaggy lines. Now, same thing happens here. Okay, cold air is going to descend on that ice cap. So you get the air coming down. Now, at about 30 degrees, okay, because this is a long ways, I believe the Earth is about 25,000 miles around. 10,000, yep, 25, it's 10,000 kilometers from the equator to the pole, and 40,000 kilometers is equal to 25,000 miles. So at 60 degrees and at 30 degrees, we will have alternating or high pressure. Oh, that's what I got right in there too. We have descending air is called high pressure. Okay, high pressure. So this is a high pressure zone. This is a low pressure zone. Okay, air is being lifted. Now, typically, low pressure is going to generate clouds. Okay, so at the equator, it's typically hot, sticky, and rainy. Okay, these clouds are going to rain. That's where the Amazon rainforest is. That's where many of the Indonesian rainforests. Our rainforests are located around the equator. Okay, now we have high pressure zones at 30 degrees. So another high pressure zone. And the poles are also high pressure zones. Now we have another low pressure zone at 60 degrees. Okay. Now I'm not talking temperature, I'm talking latitude. And we'll run through latitude with you guys later on. Hopefully you guys haven't forgotten your latitude and longitude. Okay, there are alternating low pressure zones. And again, low pressure is associated with clouds and rain. High pressure is associated with sunny days, right? Rain's falling up here. Here, this low pressure zone. Okay. Now, so there we have our low pressure and high pressure zones. So now as this air will actually flow down and try to fill in the void that's being created by this air here. Okay, but the crazy thing is the earth is spinning, and so it won't just flow straight. This air will actually come down across the globe like this. Okay, so as it comes across, those are known as your trade winds. Okay. These are highly predictable winds that follow the equator, north and south of the equator. And now, you might ask what this belt in here is called, because typically right along the equator, these are known as the doldrums. That is where there's very little air blowing, it goes straight up. Okay, so ancient sailors did not like the doldrums. They would get caught in them sometimes if they were across the equator and have problems. Now this air up here comes to that low pressure zone, and this low pressure zone flows from the pole down here. Okay, and it repeats north and south of the equator. They are the same, so you just draw your arrow to fill that in. Now those winds, let's see what the poles do. When these come down, they, just like the trade winds, they will blow around the pole. Okay, same with this, mirror image, around the pole. Now, winds are named for the direction that they come from. These come from the east, and so these are known as polar easterlies. Okay, polar easterlies. Now, air does have to rush back around to fill that in, and so we get these winds across the mid-latitudes. Now, mid-latitudes is 30 degrees, that's 60 degrees, 90 degrees, and 0. Same with these up here, 30 degrees, 60 degrees, 90 degrees, and then these are known as the westerlies. Okay, they come from the west. Now, can anyone tell me what date this is going to be on? Okay, because the Earth is constant, it's on a slight tilt. And so what is the date that we have the sun directly over the equator? There's two dates. They're known as equinoxes. Okay, this is for September 30, but 23rd, or March, I believe 21st. So this is when the sun is directly over the equator, the equinox, meaning equal night. Okay, so There is your basic wind pattern, your wind belts. Next one I'm going to show you is going to be based on one of the seasons, one of the solstices.